Okay, we are now in motion in the circle. Just review what we have covered last week. Right, this is the syllabus. Uniform circular motion. Uniform circular motion means that the body is moving a circular path with constant speed. This is circular path, constant speed, no tangential acceleration. That means compared to linear motion, we are steady uniform velocity only. Okay, that's what it means. So the speed is the same, velocity changes direction. Right? Example of circular motion, roller coaster, motion of satellite, which will cover the next topic, topic 13. Car cornering, we will do a bit of it but I don't think it will ever come out because it's probably outside your syllabus Even roller coaster also won't come out I think. Usually it come out related to gravitation Okay, linear and circular motion. In linear motion, as a vector, we are interested in displacement. Then in circular motion, instead of calling it angle theta, we call it angular displacement. That means either clockwise or anti-clockwise. It's a vector And we have velocity, right? It's moving to the clockwise or anti-clockwise, so you have angular velocity. Newton's first law tells us that when the path of a particle changes, resultant force act on the particle. Newton's second law basically allows us to calculate the resultant force acting on the particle. Right, we'll be using this one further. So that is the resultant force. Right, that's the resultant force acting towards the center. Right, in terms of time, linear motion and circular motion is the same, except that instead of displacement, we call it angular displacement. Instead of velocity, we call it angular velocity. Instead of acceleration, we call it angular acceleration. We use alpha. Right? Relationship between displacement and angular displacement S equals to alpha theta Same like your maths
Jack, I got a question.
Say again.
I got a question.
Okay, ask.
This chapter is chapter 1. Chapter 1, is it? A2 chapter 1? Or is it chapter 12?
It's called chapter 12. Textbook, I don't know but syllabus chapter 12.
Teacher, then A2 got come out A1 stuff or not?
Assume They won't test you a lot of A1 but assume that you know
Oh,
But majority will be A2 stuff But
they won't
related
ask
thing
A1
can come
questions,
out
right?
Related thing can come out
Or let's say like nuclear physics, no, right?
Nuclear physics, we will study again. So you assume that you have known your AS, so it comes out, it will test you mainly A2 Bit of
Okay.
understanding of like writing nuclear equation, that one you require to know That one is AS
Okay.
Right? V equals R omega, and A equals to R alpha. Right? A force causes linear acceleration, while a torque causes angular acceleration. Angular velocity changes but we are not interested in that Right? We only study torque in topic 5 or topic 6, where we cover moment. But in this topic, we are not interested in torque at all. Right? Not required. So alpha equals 0, or angular acceleration is 0. Okay, what are the terms you are likely to use? Right? Either small r or big R, radius of the circle. C is the center. V is the velocity. Or sometimes we call it tangential velocity lah, to qualify it as a tangent lah. Instead of angle, we call it angular displacement lah. It's either clockwise or anti-clockwise. And omega, angular velocity. Right? This one you have to memorize. It can come out. Maths won't come out. Physics will come out. Right? Where theta equals to 1 radian if this arc length is r. Right? If you have problem remembering it, just draw diagram. No? 1 radian is the angle subtended at the center of the circle where the arc equals the length of the radius. The thing to remember is 2 pi radian is 360 degrees, that's all. The others you can derive it. What's the relationship between the following parameters? Theta in radian, r radius, s arc length, is r, s equals r theta. This type of thing also can come out lah. It has come out, I think, 1 or 2 times already. Show that 1 revolution is 2 pi radian. Right? 1 revolution, the circumference is 2 pi r. Then arc length is r or theta. So from there, you want 1 revolution is the angle lah. You want the angle. So theta is s over r. S is 2 pi r. And r can cancel off 2 pi radian. And that's how we show it. This is the same thing lah. Unit for angle is theta is in radian. It's a vector quantity. And the next term we introduce is angular speed or angular velocity. When we say angular speed, it's more of a scalar lah. We stress that it's a scalar. Rate of change in angle swept out by radius. Right? In terms of formula, omega is theta over t. Angular velocity is a vector either clockwise or anti-clockwise. Means it has direction beside magnitude. Unit is radian per second. For a particle moving with speed v in a circle of radius r, how is the angular speed related to v and r? Need to memorize that, no? Right, let's look. Let's show that v equals r omega. Right? Simple formula. V equals to s over t, distance over time. If you consider velocity, that is displacement over time. So r is the radius of the circle. S is the arc length. So replace the s with r theta. So become r theta divided by t. So theta over t is the omega. So that's how we derive our equation. What's the period of revolution? Is the time period is the time for the object to complete 1 revolution. Frequency, either symbol F or Greek alphabet nu, it's like speed lah, but it's actually called nu lah. Greek alphabet is the number of complete revolution per unit time. Revolution per second or hertz or cycle per second. Right? Frequency equals to 1 over t. Same as waves. right? Same as waves. Relationship between T and omega. T is the time for object to complete one revolution. One revolution is 2 pi radian. So we use our definition of omega is theta over T. Then replace our theta with 2 pi. One revolution. So the time becomes a period. Either you memorize it or you derive it from the definition. Right? Sometimes they can call omega as revolution per second, but you need to know that is frequency. You have to convert it. One revolution is 2 pi. So omega is 2 pi f. Okay, during the break, you can try the worksheet afterwards. Right, so we have covered all these topic, radian, angular velocity, this formula, and you need not to use, and then 2 pi radian is 360 degrees, and omega is 2 pi over t, right? Definition omega is theta over t, and then second part, centripetal acceleration and centripetal force. Remember to pass out your assignment.
What assignment?
I send you already waves, superposition.
Oh,
You can either treat as a test or assignment.
I didn't see it.
But don't go and check the answer from past year paper. Okay, so that's your syllabus, centripetal acceleration and centripetal force. Okay, let's go to Newton's first law of motion. Right, if it's moving velocity u, and that's the path. If no resultant force act on the moving object, the object move with constant speed in the straight line. Or velocity doesn't change. If it's moving in a straight line, it continues to move in a straight line if there's no resultant force. Throwing a ball horizontally, where a resultant force acts perpendicular to the moving object. The resultant force is the weight or gravitational force. The force changes the direction of the object. That's the path. Does the speed increase? Yep. Does the speed increase? Yeah. The speed increase. Horizontal velocity or horizontal component remain constant. Vertical start to increase. So the resultant velocity increases. Okay, let's apply Newton's first law to circular motion. That's the velocity u. That's the centripetal force towards the center. In uniform circular motion, the force is always perpendicular to the velocity. Right? You can either say the force is perpendicular velocity or the force is towards the center of the circular path. The speed, keep in mind the speed remains constant. Force do not increase the speed because the force is always perpendicular to velocity. It changes the direction only. It doesn't affect the speed. Okay, the speed remains constant because the force is perpendicular to the velocity. Velocity changes direction. The speed stays the same. Direction changes as well. Velocity changes. So the force is always pointing towards the center. Right? Linear motion and circular motion. Now we are just repeating the whole thing. Angular displacement, where you have displacement in linear motion, velocity becomes angular velocity. Right? Remember this time, angular velocity is constant or speed is constant. An object in circular motion accelerates. When a body moves in circular path with constant speed, its velocity changes direction. Right? Speed stays constant, velocity changes direction. So where there is a change, right? Remember velocity is a vector quantity. So wherever there's a change in velocity, there's a change in direction, there's a change in velocity. So acceleration is the rate of change in velocity. Magnitude and direction of acceleration. Centripetal acceleration is the acceleration perpendicular to the velocity. Right? Direction here, velocity, centripetal force and centripetal acceleration in the same direction, perpendicular to the velocity. Direction of acceleration is towards the center of the circular path and is given in magnitude. Memorize v square over r or r omega square. Right? You're supposed to know how to use it and recall. When in the syllabus, it says that recall and use, then it's not in the formula sheet. Don't worry about derivation. If you can understand it, good. If you cannot understand, doesn't matter. Just to give you a fair idea that physics is based on maths and there's a lot of derivation. But Cambridge has cut down the number of derivation so that you don't have to be burdened by all this derivation. Because you can know how to derive, but you don't know how to apply. So Cambridge A level is more towards applying your knowledge.
Okay.
Okay, that's the starting point. The velocity is u, initial velocity. Magnitude is v. And then it moves a short time later, delta s, delta time, delta t. It moves arc length, delta s, a small distance, and a small angle, delta theta. And then the new direction is v. V still stay the same. Right? Final velocity is v. Distance move is delta s equals to r theta. Right? The distance move, the small arc length is r times delta theta. Then change in velocity. Right? We are going to use definition for acceleration, so we have to find change in velocity. The change in velocity is v minus u. This is a vector equation. So we draw our v first. That's our v. And our u, that's our u. If it's plus u, but we want minus. Right? So that's our angle theta. Right? This is a quadrilateral. Quadrilateral. So this angle theta, delta theta equals to the angle delta theta. Okay. So here is minus u. Minus u is the other way around. Minus u. And there's your vertically opposite angle. There's your delta v. Right? Change in velocity. Okay, so change in velocity, we think of this as a radius. V, V is a small angle. So this is the arc length. That's why we get V delta theta. Right? From here, we can replace our delta theta by delta S over R. Delta S over R. Right? So we use our definition for acceleration. Delta V over delta T. That's our delta V. And our delta T there. Right? That's our R. And our delta T. So delta S, delta T is your V. So straight away we get our answer. Right? V squared over R. Okay, let's make the angle the time becomes smaller and smaller. So the angle becomes smaller and smaller. Delta S becomes smaller and smaller. So initially is that direction from a previous example. That's delta V. Now we make this angle become smaller. So our V changes direction. Right? Our U still stay the same, initial speed. Right? Minus V still the same. But we see that delta V now becomes more and more vertical. Right? More and more vertical. So if we make our delta T approaches 0, delta theta approaches 0, B approaches A, V approaches U, so it becomes perpendicular. Okay, so condition for circular motion, speed constant or force constant in magnitude. Magnitude only, not direction. Force always perpendicular to velocity. Or force is always towards the center of the circle. Right? Then you need to show direction. Right? That's your particle. That's your velocity. So this is acceleration. Right? This is acceleration. Perpendicular or towards the center. The force causing the particle to move in uniform circular motion is called centripetal force, as it is pointing towards the center of the circular path. Remember, it's the resultant force. We know the magnitude of the resultant force, that's all. But it has to be provided by by something. Right? It cannot just move in a circle. It must be provided by something. We will look at some example. If the mass of a particle is m and moving with a velocity v or angular speed omega in a circle of radius r, and our resultant force is F equals to ma, say Newton's second law. So we have a centripetal force mv square over r, or mr omega square. Okay, so far, any comment or any question? Not anything not clear?
Okay.
Basically using equation only, using formula. Right? Car cornering. Example, car cornering, what provide that centripetal force there? Friction. Right? This person swinging the usually is rubber band, not cork. Cork is too light. Rubber band in a horizontal circle. So the tension in the string provide a centripetal force. This is what we are more interested in. This is the experiment. Right? Satellite, planet moving around the sun, or satellite moving around the earth. Right? So planet moving around the sun, gravitational force of the sun on the planets. Satellite moving around the earth, the centripetal force is provided by gravitational force of the earth on the satellite. Motion in vertical circle with constant speed. I think you will study your in further maths again under mechanic part, where the speed cannot be constant but we don't want you to be confused with too much right? So for physics we simplify to constant speed which is not possible right? A bulk of mass m move with constant speed in a vertical circle of radius r and center o. Right? That's your circle and your circular path. Center o is the center, r is the radius. That's your mass m. That's the string. At the bottom, what are the forces acting? So far, it has not come out. Long time ago, during the 90s, it come out, but now it has not come out. As I say, some of the things we study is more for knowledge, just in case it come out. Okay, so that is your velocity, V, forces acting on the box, weight, mg downwards, T is the tension upwards, right? That's your mg, acting downwards, tension upwards. So since it's moving a circle, the resultant force is upwards, right? The resultant force is the centripetal force. So T minus mg give you the resultant force upwards. Right? That's why we derived just now tension TA. So the resultant force is given by mv squared over r. So we replace that resultant force in mv squared over r. So TA, right? Take mg across there becomes positive. So we find that the tension is the maximum here at the lower point. So it's likely that where it will break this lowest point. Okay, let's look at the top there. Resultant force is downwards, the same. Resultant force still downwards, right? But what are the forces acting? Mg acting downwards. Tension is also acting downwards. The resultant force is T plus Mg. Applying, that's the resultant force. So T plus Mg equals to Mv squared over R. So T is Mv squared minus Mg. Right? This is the minimum. Tension is minimum at the top there. Right? Let's summarize for you the same thing that we did. Okay, try this question. Before I give you the answer, see whether you can get the answer 0.88 Newton. Just using the formula that I've given you. Mv squared over R or R omega squared. Right? Tension provide the centripetal force. Can get the answer?
I'm trying to find this question.
We are finishing in 10 minutes time.
Okay.
So remember to try the worksheet. Right? Tension provides the centripetal force. Change everything to SI unit. R is 1 meter. Right? Mass is 0.05 kilogram. Speed is 4.2 square. R is 1. So your answer should be 0.88 Newton.
Okay.
Okay, Okay, question. Experiment in horizontal motion in horizontal circle. Can the string be truly horizontal?
No.
Why not?
Uh, the tension balance the weight.
The what? To
The
what balance the
tension.
weight? The string must
Tension.
slant. The string must slant so that the tension provide a component to balance the weight. Beside another component to provide the centripetal force. Right? No. The vertical component of tension balance the weight. Usually we use a light rubber band, right? But we assume it's horizontal. Angle is too small. Right? That's the reason. It has to slant because your tension becomes your T cos theta, T sin theta. So T sine theta is balanced by mg. E cos theta provides a centripetal force. Car cornering, I won't go into too much detail lah, but if you want, I send you the slide, you can go over that. Right? It never come out lah. So what's the point of spending too much time on that? Any motion in a curved path represent accelerated motion. Right? As long as you move in a curved path, speed constant, velocity changes direction. So there's a resultant force acting towards the center. So that's the curved path. So you can think of this, the car is moving in a circular path. So that is your resultant force, centripetal force. So centripetal force is provided by friction. Right? You call it centripetal force because it's center seeking force. And magnitude is mv squared over r. Right? Friction provides a centripetal force when cornering. So friction equals to mv squared over r. Okay, you won't bother about that. Idea is that if you move too fast cornering, your car will tend to move to the right lah. That means you want to move to a bigger circle. Bigger circle, R becomes smaller. So your friction can balance your centripetal force again, right? If your speed increases. Okay, you won't bother about that. Right, so cornering, your car can either overturn or move into a bigger circle, cause speeding. Okay, this for paper 5, motion in a circle. To investigate how the period of oscillation depend on the radius of the circular path. Right? There's a bob or mass M. There's a radius, length L. There's a plastic tube. And you can put a paper marker here. Right? There's the mass M. Provide the tension in the string. Right? Yeah, required to paper 5 is required to take, these are what is required in paper 5 lah. First, apparatus requirement, and diagram and description of the setup, control variable, how to vary and measure the independent variable, how to measure the dependent variable, meta-analysis, safety consideration. Right? Usually they'll give you a formula. They won't ask you to derive. Right? But let's roughly go to the formula, how to derive it. Right? There's your weight going down, your tension going up. There's a mass of the box. There's your tension. Right? The tension is the same. For the box, the tension equals to m omega square L. Right? Angular velocity. L is the radius. For hanger and the slaughter mass, where it doesn't move up and down anymore, right? Where it reach the marker, reach the edge of the tube, then there's equilibrium. Tension equals to mg. So that's how we get the formula. Mg equals m omega square L. Then omega equals to 2 pi over T1. T1 is a period, I remember. They are giving you the formula to investigate how the period of oscillation depend on radius. Depend on radius. Rewrite the formula. Replace omega with. They won't give you a direct formula lah. They give you a formula. They expect you to use your formula to play with the formula to get your period. Then rewrite the equation. Yeah, that's a gradient. You are supposed to plot a graph of t square L, t square 1 against L. Right? L is the radius, is the independent variable. Dependent variable is T1. Right? There's one mark there. How do you measure L? Right? Measure using a meter rule. Place a marker on the string, and when it reaches the base of the tube, L can be determined later on. Right? You measure the time for 20 oscillation. There's your period. The period is just the time divided by 20. You need a fiducial marker. That means you need a reference point. So you can put a retort stand nearby so that when the swing past the retort stand, there's one cycle. Right? Repeat the timing. So this one will be worth 1 or 2 mark. And plot a graph of T1 square against L. What do you expect the graph to be? A straight line passing through the origin. Right? 1 mark or 2 mark. Then gradient. That is the gradient. And then T equals to mg. M is mass of hanger and slaughter mass. We kept that constant. How do we measure the slaughter mass? M and M. You can measure using the top end balance or electronic balance. Okay. Right. We have gone over that, so you can just refer back to your note. Safety precaution, memorize. Wear goggles. Ensure that no students are around the place when the experiment is carried out. Stop the swing. Lower the string to behind the shoulder. Rubber band should not be too heavy. Move the edge of the glass tube over a flame so that it does not cut the string. Okay, recall centripetal force and use centripetal force equation. Okay, so these are all the formulas that you need to remember for this topic.